right, so we're picking up at number 14. We're going to examine the following table. This is what we did in the very last lesson. We want to decide what the pattern is, and so what type of function it is. When I look here at my domains, 10, 15, 20, 25, 30, what's happening there? We're adding by 5 each time. So that is finding a sum, right? We're doing a sum of 5 each time. On my right-hand side, what's happening? It doesn't look like I'm multiplying by anything, although we can see if I were to do 19.6 divided by 12.1, that would be 7.5. Am I multiplying each time by 7.5? 19.6 times 7.5 is 147. So that's not going to work. So let's check for second difference. If I do 19.6 minus 12.1, it's 7.5. If I do 41.1 minus 19.6, that's 21.5. If I do 76.6 minus 41.1, that's 35.5. And if I do 126.1 minus 30 or minus 76.6, that's 49.5. So then when I look at my second difference, 21.5 minus 7.5 is 14. 35.5 minus 21.5 is also 14. That's a good sign. And 49.5 minus 35.5 is also 14. So we have a pattern of sum and second constant difference. Which means this function is quadratic. Questions on 14. Okay. Let's go look at 15. Let 256 e to the 8th, y to the 4th, to the 1/4 equal a, e to the b, y to the c. What are the values of capital A, B, and C? So this 1/4 has to be applied to each one of these. When you have a fraction exponent on a regular number, you're taking that root. Remember, this is the power, so the first power, and then this down here is the root. So when I use this number here, it's really going to be the 4th root of 256. And then when it goes to e's or exponents or pi's or anything like that, then you're going to multiply the exponent by the exponent on the outside. So it'll be e to the 8 times 1/4 and y to the 4 times 1/4. So first I need to figure out what is the 4th root of 256. So if I come over here and I do 256 and I divide that by, what do you want to divide it by? Small, easy number to divide by. 4? Okay, what's 256 divided by 4? It's what? 64? That's good. That's divisible by 4. We're trying to take the 4th root, which means we want something that divides into it 4 times. 4 goes into 64 how many times? 16 times. 4 goes into 16 how many times? 4 goes into 4 how many times? So, do I have 4 4s? Yes. So that means that this can be rewritten as just 4 times e to the, what's 1/4 of 8? 2 times y to the, what's 1/4 of 4? That's 1. So my a is the number in front of the e, which is 4. B is the exponent on e, which is 2. And c is the exponent on y, which is 1. Questions on 15? Okay. 16, which of the following functions belongs with the graph below? I can see all of my choices are all exponential. If I think about the parent function for an exponential, it goes through 0, 1, and it has a horizontal asymptote at 0. So I can see that this graph has moved. Where has it moved? Will somebody grab the door? Down 2. So which one of these shows an exponential that's been moved down 2? C. My minus 2 on the outside means that whole thing has moved down 2.
This is here. Here, that page.
Yes, Aurora.
Okay.
Oh, at the end of period. Pause. All right. Everybody who watches the video will know. All right. The given expression can be written as a single logarithm and simplified such that ln of e to the second plus ln of e to the 7th equals ln of e to the x, which equals just x. So remember, when you're adding logs, if I'm adding this log that's a base e plus this log that's a base e, if you're adding two logs that have the exact same base, then you can multiply the two ofs. So this is really ln of e to the 2nd times e to the 7th, which means I do what with those two exponents? Add them together. 7 plus 2 is 9. And remember, if these both have the same base, remember that's really log base e of e to the 9th. If these two things are the same, then my answer is just the exponent. In this case, that is 9. So what is the value of x? 9. Questions on 17? All right, let's look at 18. So this I can see is my change of base rule. My change of base rule. And I can see that these both have the same base. They're both base 3. So that can be combined into one log with a new base, where the of in the denominator is the new base, and the of the numerator is the new of. So this is going to become log. My new base is going to be 6, and my of is going to be 216. Now, it says log base b of n. I have that, log base b of n. It says it just equals x. That means there's a way to write 216 as 6 to something. So I need to figure out what multiplies to itself 6 times and makes 216. So if I come off to the side, what's going to multiply to itself 6 times to be 216? What's something that goes into 216? Think little. Think littler. 3 does not go in. 3 would go in, actually. 6 goes in. How many times does 6 go in? So 6 goes in 36 times. And then 6 goes in there 6 times, and then 6 goes in there 1 time, but that only gives me 3. So that could be rewritten as 6 to the 3rd power. So I can write this as log base 6 of 6 to the 3rd power, which is going to be, remember, if your base and your of are the same, then your answer is just the exponent 3. Okay? So what are the values of b, n, and x? B, my base is 6. N, my n was 216 before I simplified it. And then my x turned out to be the whole thing just equals 3. The reason I know that my n, they wanted the 216 and not the 6 to the 3rd is because this is just a plain number. It's not a number with an exponent attached. So I have to go back to where last time my log had just a plain number as the of. Okay? Questions on 18. All right, 19. Log base 4 of 1/5 plus 1/2 times the log base 4 of 25 equals 1/2, or equals x. What's the value of x? Remember, if you have a number multiplied in front of a log, we can rewrite it where that number is really a what? An exponent on the of. So this can be rewritten as log base 4 of 1/5 plus log base 4 of 25 to the 1/2. Remember, we just talked about when you're taking a fraction as an exponent, it's the power over the root. So I'm really square rooting the 25. So what does this really become? 5. This is really log base 4 of 1/5 plus log base 4 of 5, because you're really square rooting that 25. When you're adding two logs together that have the same base, then you can multiply the two ofs together. So this is really log of 4 of 1/5 times 5. I'm going to come over here. I ran out of room. So that's log base 4 of, what's 1/5 of 5? 1 equals x. Now, in order for this to simplify as the same number, I need to figure out how I can write it as log base 4 of 4 to the x power, because that's how I'm going to end up with what x equals. But, so 4 to the x needs to equal 1. What power do you raise something to make it equal 1? 0. So this is really log base 4. We can write it as 4 to the 0. And then we know if these two are the same, then my answer is just, in this case, x equals 0. Questions on 19. Okay. Select the statement that best describes the transformation of this function. F of x equals log of x plus 2 minus 4. What does the x plus 2 inside the of do? Moves 2 where? Left. And then my minus 4 on the outside, what does that do? Down 4. So what's my answer? Left 2, down 4. A. Left 2, down 4. Questions on 20. Okay. All right, the function h of x equals log of x plus a plus b is graphed below, and the parent function has been graphed as a dashed line for context. What is the value of A? What is the value of B? So if I look at my parent function, I like to compare this point because that's going to help me easily see what happened. I am moving. How is this graph moving? To get from here to here, what's the shift? 2 down, right 1. Down 2, right 1. So if I'm going to go down 2, is that the A or the B? And what's the value of the B? -2 if I'm going down 2. And that means A must be the 1. If I'm going right 1, what's A? -1. Questions on 21? Okay. What is the vertical asymptote for the given function? So if I think about, let's talk about the parent function real quick. The parent function for a log has a vertical asymptote of y equals 0. Or sorry, x equals 0. This is my parent function. This is just log of x. Okay. What does the negative out in front do? Reflects. Does it reflect it across the x or across the y? The x. So that's going to take this graph and it's going to turn it so now it's going to look like this. That's just putting the negative on it, right? That's the log of just -x. Okay? Now here's where we get tricky, is this in here. I have to rewrite this. Instead of 2 minus x, this is really, we can think of it as -x plus 2, but then I need to factor that negative out of both of these terms. So I'm going to write it as -x minus 2. I should have done all that in green. Fixed it. Okay. So this piece in here, this negative, is going to, I'm actually going to do it in pink. The negative that we factored out, that reflects it across which axis? Across the y-axis. We already did across the x-axis. So this negative inside is going to reflect us across the other side. So I'm going to take this orange one because we already did the negative out in front. And now I'm going to reflect it so it looks like this. My vertical asymptote is still going to be here at 0, right? It hasn't changed. So now this one is log, negative log. Oh, that should have been a negative out in front, not there. Of -x. It's been reflected over both axes. And then what does this -2 do? Right 2. So that means it's going to take my vertical asymptote that I already have, and it's going to take this point right here, and it's going to move both of them over 2 units. So this one's going to go right here. My vertical asymptote's going to move to here, and my graph is going to move to here. This is negative log of -x minus 2. And then I still have that +1 on the outside. That +1 on the outside does what? Shifts the whole thing up 1. Is that going to affect my vertical asymptote? No, that's just going to move the whole thing up 1. So my graph is going to look something. My final graph will be this purple graph. But the question is asking about the vertical asymptote. My vertical asymptote, verticals are x equals equations. What is x equal for my vertical asymptote? The whole thing shifted to the right 2. It used to be 0. It shifted to the right 2. X equals 2. Questions on 22. Now we're going to 1. Don't ask me about the numbers. I don't know. All right, which of the following functions belongs to the graph below? Okay, so let's talk about what's happening. These are exponential, which means normally it would look like this, something like this. That's what it would normally look like. I can see, my goal is to get to this point right here. It looks like it has flipped over this both ways, right? It looks like it's flipped over this way to get it to be upside down. So that's going to be, to do that, that's going to be putting a negative out in front of the exponent. But then it also looks like, right, it's going to the right. So it also has flipped over this way. So that's putting a negative on the x. And then from there, it's moved how far? To the right. How far? 5. And then it's moved where? Down 1. So that means my negative e to the negative, my x has moved 5 to the right. So that's going to be x what? Minus 5. And then I've moved down 1, so outside that's going to be minus 1. Now I don't have any exponents that look like negative times an x minus 5, right? None of them have negatives being multiplied on the outside of them. I know it's not these with the 4s. So I'm going to distribute that negative in and say it's negative e to the negative x plus 5 minus 1. Do I have any negative x plus 5s? I do not. I'm going to rewrite this so it's negative e to the 5, because it's a plus 5, and a negative x minus 1. Do I have that option? 5 minus x minus 1, C. Questions on this number 1? We have to be comfortable with all our transformation rules. Okay. 23. Just pretend the numbers are normal. There was just a random number 1 in there. All right, 23. Estimate the answer to the following question. 2 to the x equals 120. So if I think about when I multiply 2 to itself, right? 2 times 2 is, and then 4 times 2 is 8, and then 8 times 2 is 16, and then 16 times 2 is, and then 32 times 2 is, and then 64 times 2 is 1. Well, now I'm too big, right? Because I'm trying to be 120. So how many 2s? So 64 and 128. It takes 1, 2, 3, 4, 5, 6 2s to be 64, and it takes 7 2s to get to 128. So that means x has to be between what two numbers? In between 6 and 7. Which one is it closer to? 7. 7, right? Because 120 is closer to 128 than it is to 64. Questions on 23? Okay, Scientific notation, when we're multiplying, remember what we're going to do is we're going to multiply our regular numbers together. And then we're going to multiply our tens together. So I'm going to do 9 times 2 times 10 to the negative 4 and 10 to the 7. 9 times 2 is 18. Times, and then here for these two, I'm going to add the exponents when you multiply. So that's going to become 10 to the negative 4 plus 7 to the 3. Are we in scientific notation? No, I need this one to be 1.8, which means 18 down to 1.8. This side's getting smaller. So this side has to get bigger by how much? We move the decimal one place. So 3 becomes 4. So b times 10 to the n, 1.8 times 10 to the 4, b is 1.8. 10 to the n, 10 to the 4, n is 4. Questions on 24? Okay. Amortization, it says you may use a calculator. Yay! I like that you all participated in my cheering. Okay, so remember what I like to do. I like to, when they give me a formula, I like to organize my data. So I've got A sub 0, I've got R, I've got N, and I've got T. If you invested $600, so that's what I'm starting with, at an annual rate of 8.5% interest, so that's my rate, R, 8.5%, which remember we're going to write it as a decimal, 0.085. Compounded quarterly, what does quarterly mean? 4 quarters in a dollar, 4 quarters in a year. So N is the number of times we add the interest, 4 times a year. How much will you have after 5 years? So my time is 5. So we're just trying to solve for A. That's an easy one. I like this one. A sub 0 is 600 times, can somebody grab the door, please? My rate is 0.085 over my N is 4. Raised to the N times T power. If you want to change that to 20, you can. I'm going to put this, since they're telling me I can use a calculator, I'm going to put that whole thing in the calculator at one time. So I'm going to do 600 parentheses 1 plus, I'm going to hit control divide to make my cute little fraction, 0.085, arrow down, over 4, arrow out of my parentheses and raise the whole thing to the 4 times 5 power. If you want to just raise it to the 20th, you can. When I hit enter, it says to answer to the nearest cent, right, because it's money. So we're going to go to 2 decimal places, 913.68. So 913.68 is how much we're going to have at the end of 5 years. So that's not bad. We made $313. Questions on 25? Okay. Here's another one. Using the amortization function, they gave me the equation. So I'm going to do the same thing. I'm going to organize my data, my A sub 0, my rate, how much it's compounded, and for how long we're investing. All right. If an investment has a 4% annual interest rate, so that's my R rate, 4%, which we're going to write as 0.04. And it's compounded monthly, so monthly means 12. How many years will it take to double in value? So this one seems weird because it seems like they didn't give me enough information. But I know I'm trying to double whatever I invest. So let's think of an easy amount of money to invest. What would be a really easy amount of money to invest to work with mathematically? 1. Let's invest $1. If I want to double my $1, how much do I want to have at the end? $2. Now we have nice little itty bitty tiny numbers to work with. I love it. Okay. All right. So A is 2 equals A sub 0 is 1 times 1 plus R 0.04 over N 12 to the N 12 times T power. Now, normally we would divide by that 1 in front. You don't really have to in this case because when you're multiplying by 1, you don't really even have to write it. But if you wanted to see it there in case you had a different number there and you want to know how to get rid of it, right, you would just divide. But we still end up with just 2 equals and then my parentheses. 1 plus 0.04 divided by 12 to the 12 times T power. Okay, now anytime you have a variable in an exponent, that's when you have to turn it into a log to get the variable out of an exponent. Anytime you have a variable as an exponent, you have to turn it into a log. And remember, I say the base to the answer equals the of. The base to the answer equals the of. Now, normally I write it as the base of the answer, and then I say equals the of, and I put the of on the right-hand side and the base to the answer. But the base to the answer is my exponent side. So I'm going to write that on this side. It's the base to the answer equals the of. So once I do that, it's real easy for me to see when I'm converting this into a log what my of is. What my base is. It's okay for my base to be ugly because we're going to use a calculator. And what my answer is. So let's convert this into a log. Log, what's my base? What's my base? Yeah, it is 1 plus 0.04 over 12. That's my base. It's a weird base. That's okay. What's my of? 2. That's not an exponent, right? Because this is a base. It's log of 2. That just has this weird base. Log of 2 with this weird base. Equals the answer. What's the answer? 12? 12 times T. All right, if I'm trying to solve this for T, it's almost solved for, but I've got this pesky times 12 in front of it. How do I get rid of the times 12? Divide. So when I do that on the right-hand side, I've just got T. I just need to put this left-hand side in the calculator. It's ugly, but that's okay because we have a calculator. It doesn't matter that it's ugly. I'm dividing this log by 12 just so it looks like I want it to look. I'm going to hit the control divide, and I'm going to do control to get my log. All of this ugly thing is the base. The 1 plus, I'm going to make another little fraction down there, 0.04 over 12, right? That's my base. And then my of is just the 2. And then I'm dividing that whole thing by 12. So I typed in the calculator exactly what I have here. And when I hit enter, I get 17.3575. It says to round my answer to the nearest tenth, so that's one place. So that's going to be 17.4. So it's going to take me 17.4 years to double my money. That seems like a really bad way to make $2. Let's not invest $1 in that account. Questions on 26? Okay. Let's look at 27. You get to use the calculator again. This time we're continuously, so look, we have a different formula. We have an A. We have an A sub 0. We have an R. And we have a T. We don't have an N this time because it's continuous compounding. So we invest our money into a savings account that compounds continuously. What would the interest rate need to be to double your money after 10 years? So they only gave me 10 years, but I know I want to double my money. How much do we want to invest that we want to double? Let's invest $1. So that way when I double it, how much do I end up with? 2. Make your life easy. Use small numbers. Okay. All right, so $2 is the result when I invest $1, e to the r times 10. Right? So we could do the same thing we did before. We could divide by 1. You don't really need to because you don't have to even write the 1 there. So I've got 2 equals e to the, I'm going to change it to 10r just because it looks prettier. 10 times r looks prettier than r times 10 to me. All right, so I want to change this into a log. So remember, we're going to do the base to the answer equals the of. So when I do this, what is my base? What's my base? E, which means we could do the natural log, right? Because that's log base E. The log base E of, what's my of? 2. Equals the answer, what's the answer? 10r. How do I get r all by itself? Divide by 10. So the natural log of 2 divided by 10, or log base E of 2 divided by 10. You can do it either way. The natural log of 2, arrow out of the parentheses or close the parentheses, divided by 10 gives me 0.069315. 0.069315. 0.069315. 0, I already forgot it. 69315. I tried to remember it. Equals my rate. It says to write it as a percent and round to the nearest tenth. So if I move this over 2 places to write it as a percent and then round that to 1 decimal place, it's going to be 6.9% is my rate. Questions on 27? Okay, we probably only have time for one. Oh, you know what? We will save these for the next one.